So polynomial long division is something that we need in several different upcoming math concepts that you'll learn. So we're going to learn it here because it's going to help us find zeros of polynomial functions. So it's probably review for you, but it's a good practice and it will be really useful to you later if you're just really smooth and fluent in it. So I want to continue to stress the equivalence of these four statements to make sure you're realizing that if I tell you that 4 is a real zero of some polynomial function f, that means you know that 4, 0 is an x-intercept on the graph. So if you were trying to graph, that would be really helpful information. It means x minus 4 is a factor of the polynomial. That means it divides evenly into f, and that also means that the quotient is another factor of f. And then we also know that f of 4 equals 0. So make sure you're really absorbing that if I tell you one of these pieces of information, you own all of them. Okay, so the divides evenly part, that's where the polynomial long division is going to come in so that we can check for that divide evenly part. So the dividend is what you're going to be dividing into. So that's negative 4x cubed plus 5x squared plus 8. And the part that's going to go in the division box. Now we're missing a x term. We have degree 3, degree 2, and no degree 1. So you need to put a 0 placeholder. And each degree term of a polynomial is analogous or plays the same role as a number when you're doing number division. And so if you had 1307, if you didn't have this 0 placeholder here, it would be representing a different number. So please don't forget to put 0 placeholders in any degree term that's missing. Okay, so then your divisor is what are you dividing by? In this case, x plus 3. Then your quotient is going to be what you come up with in the top, doing your division process, and then your remainder will come out at the end. So the first step is to look at the first term of the divisor and the first term of the dividend and ask, what do I need to multiply the x by to get negative 4x cubed? And that's going to be negative 4x squared. Then you distribute the negative 4x squared to both terms. So you get negative 4x cubed minus 12x squared, and then subtract. So recall that subtracting a polynomial means add the opposite. So the 4x cubes are going to cancel. That was kind of the whole point. And you're going to get 17x squared and then carry down your plus 0x and your plus 8. Okay, and then we want to know what do we multiply this x by to get the 17x squared, and that's going to be 17x. Then I distribute the 17x to the x plus 3 and get 17x squared plus 51x, and I'm subtracting. So recall that subtraction means add the opposite. So the 17x squareds will cancel. And I will have negative 51x plus 8. So then I need to multiply the x by negative 51 to get a match for the negative 51x. And then it's going to be minus 153 and subtract. Subtraction means add the opposite. So I'm going to get 161 for my remainder. And my quotient is going to be negative 4x squared plus 17x minus 51. So you can check polynomial division by finding the quotient times the divisor plus the remainder and make sure that it gives you your dividend. So let's do that for this example. We're going to multiply our quotient of negative 4x squared plus 17x minus 51 times our divisor of x plus 3 and add our remainder and see how we did. So let me encourage you to use the box method for multiplying longer polynomials together to make sure you get all the terms. So we'll have negative 4x squared, 17x, and negative 51 across the top, and then x and 3 down the side. Then each row and column where they intersect, you multiply. So you're going to get negative 4x cubed, 12x squared, minus 51x, minus 12x squared, 51x, and negative 153. So my polynomial looks like negative 4x cubed. My x squareds cancel and my 51x's cancel. Except for I see an error, so hopefully you saw it too. This term should be a 17. So I should have plus the 5x squared. Then the 51x's cancel, so minus 153, and then plus the 161 remainder. So I get negative 4x cubed plus 5x squared plus 8, which was our dividend. So you should never give the wrong answer for one of these problems because you can check your work. Okay, so now let's look at how we would go about dividing by a quadratic. So we're going to divide 5x to the fourth, and then we need 0x cubed, because we don't have any of those, minus x squared plus x minus 2, and we're dividing by x squared plus 2. So we know we're going to need to multiply the x squared by 5x squared, then distribute that and get 5x to the fourth plus 10 x squared, and we're going to subtract. So we see we get no x cubed terms here, but when we add the opposite, we're going to get negative 11x squared plus x minus 2. So then we need minus 11 in the quotient to get negative 11x squared, and then minus 22, and notice how I'm lining up the like terms. So then subtracting means add the opposite, and I'm going to get a remainder of 20. So it should be true that x squared plus 2 times 5x squared minus 11 plus 20 equals what I started with. So we can FOIL this one since it's a binomial and a binomial. So we'll get 5x to the fourth minus 11x squared plus 10x squared minus 22 plus 20. So that looks like 5x to the fourth minus x squared. And somehow I lost my x. Nobody said anything. So let's back up, and I have an x plus 20 here. So there's my plus x minus 2. So it's a good way to find little errors. So I'm going to leave that in the video. And if you have any questions, let me know.